A very good morning, everyone. This is me, Aravind, and today I'm going to teach the concept of breadth first search, which is a graph traversal algorithm. So let us try to look at the problem statement first. The problem statement is to devise an algorithm to traverse all nodes of a connected graph such that the nodes are traversed in level order fashion. That is, all parents in that level are visited before visiting a child in the next level. So let us first try to devise a simple algorithm of how we can do it. So what we have to do is the first step is to visit all the nodes at the zeroth level. That is, we are going to visit the root first. And then we are going to visit all the nodes at the next level. And we are going to repeat the step 2 until we have visited all the levels in the graph. So adding a little more detail to the previous algorithm is first we are going to visit the node, and then we are going to visit the immediate children of the root node, and similarly we are going to visit all the immediate children of the nodes that we have visited previously, that is the children that are not visited yet. And we are going to repeat this step until all the nodes in the graph are visited. So, what is the data structure that can be used to solve this problem? In the previous algorithm, we saw that we are going to visit the children of the nodes that are already visited. So, what it means is we have to store the children of the nodes visited in a data structure so that they can be visited after visiting the current level. This needs a first in first out mechanism, which in turn can be provided by a queue data structure. So, adding a little more detail to the algorithm. First, we are going to create a queue, and then inside the queue, we are going to enqueue the root. So, after enqueuing the root, we are going to dequeue the element of the queue, and we are going to enqueue all the children of the dequeued element. For example, if root is the element that we are getting after the dequeue function call, we are going to enqueue all the children of the root node, and also we are going to print the dequeued element and mark it as visit, and we are going to repeat step 3 until the queue becomes empty. So this is the pseudocode for breadth first search. So let queue be the queue. That is, we are going to create a queue, and we are going to enqueue the root, which is here as yes. So if imagine this is the root of the graph, and we are going to enqueue this s, and then we are going to mark s as visited, and while the queue is not empty, we are going to dequeue an element and store it in the variable v. So while dequeuing in this queue, v is going to be s, and then for all the neighbors of neighbors w of v in graph G, that is, these immediate adjacent nodes are the neighbors of s. And see, first let us take this node. This is not listed, right? So we are going to insert this node. And next we are going to insert this node. And next we are going to insert this node and mark these as visited. And these three nodes will be inside our queue now. And we are going to repeat this process until the queue is empty, which means that all the nodes in the graph are visited. So to make it more understandable, we can see a working example in the next slide. So we can look at a working example now. So let us consider the graph with 1 as root, and this is going to be the queue that we are going to use. So first we have to enqueue the root inside our queue. So we are going to enqueue 1. Now we are going to mark the root node as visitor. So and we are going to have variable v. So now we are going to check if our queue is empty. Is our queue is empty? No. So what we are going to do is we are going to dequeue and store it in the variable v. Okay. And now we are going to print the value in variable v. And now what we are going to do is we are going to enqueue all the adjacent nodes of v that are not yet visited. So 2 is a 2 is a node that is not yet visited and it is adjacent to 1. So we are going to enqueue 2 and mark it as visited. Similarly, 3 is also another adjacent node to 1. So we are going to mark it as visited, and similarly we are going to enqueue 4 and mark it as visited. So now we are going to check if our queue is empty. No, it is not empty. So we are going to repeat the cycle again. So what we are going to do is we are going to dequeue from the queue again. So when we dequeue, the element that's going to be now v is 2 now. We are going to print it, and we are going to add all the adjacent nodes for 2 inside our queue and mark it as visited. So 5 is adjacent to 2, so we are going to mark it as visited and enqueue it. Similarly, we are going to mark 6 as visited and enqueue that too. So now we have marked all the adjacent nodes to 2 that are not visited. So now again we are going to check if our queue is empty. No, our queue is not yet empty. So we are going to repeat the same process again. Now again we are going to dequeue. So when we dequeue, the element that's going to be now v is now 3. So we are going to output the number 3 and add all its adjacent nodes to our queue. Now there is no adjacent nodes to 3. So now again we are going to check if our queue is empty. No, it's not yet empty. So we are going to repeat the process again, and we are going to dequeue the number 4 and store the variable v, and also we are going to print it. So now we have to enqueue all the adjacent nodes to 4 that are not yet visited. So what we are going to do is we are going to enqueue 7 and mark it as visited. We are going to enqueue 8 and mark it as visited. So we have covered all the adjacent nodes to 4, and so we are going to check if the queue is empty again. So is the queue empty? No, there are still 4 elements inside our queue. So we have to repeat the same process again. We are going to dequeue from the queue and store it in the variable v, and again we are going to print it. So now we have to enqueue all the elements in that are adjacent to 5 and are not yet listed. So we are going to enqueue 9 and mark it as visited. Similarly, we are going to enqueue 10 and mark it as visited. There are no more adjacent nodes to 5 that are not yet listed. So again, we are going to check if our queue is empty. Is it empty yet? No, it is not empty. There are still 5 elements inside our queue. So we are going to repeat the same process again. We are going to dequeue from the queue and store it in the variable b and also print it. Now we are going to add all the adjacent nodes to 6 that are not yet visited to our queue. We can see that there are no adjacent nodes to 6 that is not yet visited. So we are going to remove that, and the process is to be repeated again. The queue is not yet empty, so we are going to dequeue and store in the variable v, and we are also going to print it. Now we are going to enqueue all the nodes that are adjacent to 7 and those that have not yet visited. So we are going to enqueue 11. I'm sorry, I don't have space. Add something here. We are going to enqueue 11 and mark it as visited, and similarly we are going to enqueue 12 and mark it as visited. So we have covered all the adjacent nodes to 7, and we are going to repeat the same process again. We are going to check if our queue is empty. No, it is not yet empty. So what we are going to do is we are going to dequeue from the queue and store it in the variable v, and also we are going to print it. So now we are going to enqueue all the elements that are adjacent to 8 that is not yet listed. So there are no such elements. So again we have to check if our queue is empty. No, there are still 4 elements, 9, 10, 11 and 12 inside our queue. So we are going to dequeue the element again and store it in the variable v, and we are going to print it. And we are going to enqueue all the adjacent nodes to 9. There is no adjacent node to 9 that is not yet visited. So uh, we are going to repeat the process. The queue is not yet empty, so we are going to dequeue and add and store that number in v, and we are going to print it, and we are going to enqueue all its adjacent variables to the queue. There are no adjacent variables to 10, so we are going to check if our queue is empty. It is not yet empty, so we are going to dequeue and store it in the variable v and also print it, and we are going to add its adjacent nodes to the queue. There are no adjacent nodes to 11 that is not yet listed, so we are going to see if our queue is empty. It is not empty yet, so we are going to dequeue and we are going to add that node to our variable. We are going to store in our variable, and also we are going to print it. So now we are going to check if our queue is empty. We can now see that all the elements in the queue have been dequeued and the queue is empty. So this is going to be the breadth first traversal of our given example. So the output will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So thank you for watching this video.